Alright, in this video we'll be going over investigation 10.1.1. So before we get started, let's go ahead and review how to shift parabolas. So in order to shift it to the side, we're going to change the value next to the x. X measures side to side. And for the x values, they're kind of backwards. If I want to move it to the right, I'm going to actually have to minus 1 to move it to the side. And to move it up, it's going to work the way we think it would. Plus 2 is going to move it up. Alright, trying the next one. Here I want to shift it to the side and up. Alright, looks like this time I'm shifting it 2 to the right. So again, it's kind of backwards. It's going to be minus 2 to move it to the right. And it's going to go 1, 2, 3, 4, 5 up. Let's do plus 5. Looks like this one's a little bit more narrow than our original parabola. So we're going to add a coefficient here to make it more narrow. Right, and there it matches. Right, and here, this time instead of moving it right, I'm moving it left. Right, again, next to the x value moves it side to side. Again, a positive number is going to move it left. I'm going to keep moving it for, I think, 6. All right, 6 in the right spot. To move it down, I'm going to subtract minus 3. And to flip it over, I'm going to make it negative. And this parabola is a little bit wider than what we think it is. So to make it wider, let's see, is 0.5 enough? Yes. All right. So those are how we move a parabola. And moving a parabola is going to be similar to how we move a circle, which we're going to get to in just a second. So first of all, what's the equation of a circle? So here you guys can try different things to see if you can graph a circle. I don't expect you guys to figure it out right away, but I just want you guys to try different things and see if you can make a circle, right? Because I know we can make a parabola, right? We can make a negative or a parabola that's upside down, right? We know how to shift these up. But again, how can we make a circle? So that's what we're going to try to figure out. So again, go and just experiment, try graphing different things and see what happens. Okay. So in order to get the idea of a circle, let's just do a review of some basic circles. Draw a circle with radius 2. So I'm going to my pointer. Here's 2. I'm going to go to the top 2, around 2, down to 2. Right, and this has a radius of 2 because the radius from the center to the edge, this has a length of 2. So this is a circle with radius 2. Right, let's figure out the center of the circle. Let's see, 1, 2, 3, 4. So it looks like the center is right here. So let's put a point. I'm not shifting side to side, so x is 0. And I'm shifting down 4, so negative 4. Okay, what's the radius of the circle? 1, 2, 3, 4. So this has a radius of 4. Okay, let's do a few more. Looks like the center is right about here. So I'd go right 2, up 3. So the center is at 0.2 comma 3. And the radius, 1, 2, 3. Right, so radius is 3. Right, and let's do another one. Let's see, the center looks somewhere maybe here. So I'm going left 4 and up 6. So again, left 4 is negative 4. Up 6 is 6. And the radius is 1, 2, 3, 4, 5, 6. All right, moving forward. So now that we kind of get an idea of the center of a circle and its radius, let's go ahead and figure out if we can write the equation. So here we have a point. And if you move the point, what do we notice about this point? So hopefully one thing we see is there's always a right triangle enclosed inside the circle. There is always a right triangle enclosed in the circle. Right. And hopefully you notice that, again, the hypotenuse, this black line, the hypotenuse of the triangle is the radius of the circle. The hypotenuse of the triangle is the same as the radius of the circle. Right? And we know for a circle, as I shift the radius around, the radius is always going to stay the same, right? Whether if it's over here or up here, the radius is always going to be, in this case, 5. Okay? So how can I use a right triangle to help me figure out the radius? Right? So if you remember one of our theorems, Pythagorean theorem, I can do a squared plus b squared equals c squared. In this case here, a and b are these two legs, and the c squared, the hypotenuse, happens to be the radius as well. So here, 4 squared is 16. 4 times 4 is 16. 3 squared, 3 times 3 is 9. A squared plus B squared, if I add these up, I get 25. Whoops, wrong button, 25. And the square root of 25 is 5. Okay. Here, looking weird, let's look at another spot on the circle. So here's another spot. All right, notice that this has a length 3, 4. 3, 4. So we know that 3 times 3 is 9. 4 times 4 is 16. Add those up, we still get 25, and the square root is 5. So notice that when I pick 2 spots onto the circle, 2 different spots, right? If I do a squared plus b squared, I should always get the same answer, right? I should always get the same radius, because we know that the radius around the circle is always going to be the same. So the idea of using a squared and b squared to figure out r, that's going to be our equation for the circle. Okay, so again, no matter what I do, right, a squared plus b squared is always going to be 5. Right? No matter what point I make, a squared plus b squared will always make the radius 5. Okay, so that's going to be our equation. So usually the Pythagorean theorem is a squared plus b squared equals c squared. In this case here, our a is going to be x, right? X. One of the legs is x. The other leg is y. In this case, our hypotenuse is going to be r. So a squared plus b squared equals c squared. Or in this case here, x squared plus y squared is equal to the radius squared. And that's our equation for a circle. So let's go ahead and test this out. Let's go ahead and write an equation and see if it graphs a circle for us. So in this case, let's do x squared plus y squared. All right, and in this case, our radius is 5, so it will be 5 squared. And notice that I've typed this formula. Do you see how it graphs a circle for us? So this is the equation of a circle. All right, let's go ahead and write the equation for this one. Looks like this one has a radius of 6. So again, x squared plus y squared equals 6 squared. So again, x squared plus y squared. If I do the Pythagorean theorem on any of these points, a squared plus b squared, right, it should always give me 6. Okay, and one more, x squared plus y squared equals, in this case is 4, so 4 squared. So let's go and see how we can shift the parabola. So here we have something next to x and something next to y. Hopefully this looks kind of familiar to our parabolas. This is how we move a parabola side to side. Let's see, if I put a positive number, so do you see how x is becoming positive? The term next to x is plus. It's moving to the left. So adding to x moves it left. Subtracting x moves it right. So it's kind of like backwards when we think, right? Normally we think of positive on the right, but this time positive moves to the left and negative moves it right. Okay, let's try this one. Let's see, positive y looks like it's moving it down, and negative y is moving it up. Okay, so it looks like everything is kind of like our inverted controls, right? All right, adding to x moves it left. Subtracting to x moves it right. Adding to y moves it down. And subtracting to y moves it up. So everything's kind of the backwards than what we normally think, right? We usually think positive is over here and positive is up here, but it's going to be backwards. Positive moves left, negative moves right. Positive moves down, negative moves up. So with that in mind, let's go and shift this parabola. So let's see, I think it needs to be shift over left. So let's do, again, opposite, plus 1 is going to move it left. And it looks like the radius doesn't quite fit. I need a radius of 1, 2, 3, 4, 5. Let's do 5 squared. Oops, squared. Okay, let's try the next one. So I need to shift this over. Let's see, again, to move it right, I'm going to subtract. Let's see, minus 1, not quite there. Minus 5. Nope, too much. Minus 4. All right, that looks right. And now let's go ahead and make the circle bigger. This has a radius of 1, 2, 3, 4, 5, 6. So the radius is going to be 6 squared. All right, this one needs to be moved up, so I'm going to affect the y parameter. And again, backwards, subtracting is going to move it up. So let's see, minus 1. Nope, not there. 2, 3, 4. Okay, it looks like in the center. And this one has a radius of 4, so let's do 4 squared. Okay. All right, this one's going to shift down. So again, an add to shift down. plus 1. Nope, nope, that looks centered. And then this also has a radius of 4, so let's do 4 squared. And here, this one is shifted left and up. So again, I think I need to shift it to plus 4 to move it left. And to move it up, I'm going to subtract. So minus 2. Right, and this one has a radius of 3, so r squared is going to be 3 squared. Okay. So what's the equation of a circle? It's going to be x squared plus y squared equals r squared. So that's our equation of a circle. All right, here we have some additional practice problems. You could try these on our own. You flip through the tabs, you guys can see the different circles. So the first one is in the center, so I don't have to shift it. X squared plus y squared. All right, and this has a radius of 2. So again, it's not just going to be 2 by itself, it's going to be 2 squared. Okay, see, this one is shifted to the side. Left 3 means plus 3. Oops, x plus 3 squared. It's not shifted up or down, so it's just regular y squared. Or you can think of it as y plus 0, right? It doesn't shift it up at all. Right? I'll just leave it as y squared equals the radius 1, 2, 3, 3 squared. Okay. Here, this one is just shifted down. Looks like it's at -4 is the center. So let's see. So leave x squared. It's not moving side to side. It's just moving down. So I'm going to put plus 4 to move it down. All right, and the radius is 1, 2, 3, 4, 5 equals 5 squared. Okay, and d, let's see, left and then down. So plus 1 plus 2. X is plus 1, moving it left. All right, to move it down, I need to add to y. Y plus 2 to move it down. All right, and the radius is 1, 2, 3, 4 equals 4 squared. All right, so it's going to work very similar to how we shifted parabola. Adding or subtracting to the x moves it side to side. Adding or subtracting to y moves it up and down. And I can change the radius by changing the r squared back here.